so we can make sure we really understand what's happening in this little iterative Fibonacci function that I wrote. I'm going to step through it with a particular example. So we're going to assume that this function is called with the argument 5. So we want the fifth term in the Fibonacci sequence, starting at where we're indexing things starting at 0. So the 0th term will be really sometimes what you would imagine the first term to be. We'll start at the 0th term. So we're assuming that Fibonacci of 5 is called. So we want the fifth term starting at the 0th term. So we just want the fifth one. And so when we go into this program, terms is defined as this list right here that just has two elements, 0 and 1. So what I've done here is I'm going to really focus on what happens in this loop. So as we enter into this loop, the first time that we enter into this loop, terms is referring to a list that has just 0 and 1 in it. And we did that because by definition, those are the first two terms of the Fibonacci sequence. And then also entering into the loop, we define I as being equal to 2. And we do that because we've already defined the 0th term and the first term. And so now we want to, as we enter the loop, we want to add the second term as we go into the loop. And then we say while I is less than or equal to n. Well, we already know that n is 5. So in the scope of this function, while we are running it, the variable n is 5. And so clearly I is less than or equal to 5. So we will run this code right over here. And we're appending to terms. So we're going to append something. So entering into this clause, this is what I in terms look like. But it looks like we're going to append something to terms. So terms is going to look like, terms is going to be 0 and 1. And then we're going to add something. We're going to add something right over here to terms. And what is that thing we're going to add? Well, we're going to add whatever this business over here is. It seems complicated. When you break it down, it doesn't look too bad. In this situation, what is I minus 1? Well, I is 2. So in this situation, I minus 1 is going to be 1. And I minus 2 is going to be 0 as we go through this iteration. So terms, the first term in terms, the first term, so this is the 0th term, this is the first term. So the first term in terms is literally a 1. So this whole thing is 1. And the 0th term in terms, remember terms, the 0th term in terms, actually I should write it this way. 0th term, the list is called terms. The 0th term in terms, if this is what term looks like right now, is going to be 0. So this whole thing is going to be 0 as well. So it's 1 plus 0, which is 1. And that's what we're appending to terms. So we're going to append a 1 over here. And then we say I is equal to I plus 1. Well, I is right now equal to 2. So you're going to add 2 plus 1 is 3. And that's going to be the new value for I. And then we go back, we loop back up to the beginning of the while loop. And we say while I is less than or equal to n. Well, now I is a little bit closer to n. It's 3 now, but it's still less than or equal to 5. So now we evaluate this again. So once again, entering into the loop, terms now looks like this, 0, 1, 1. I looks like this, 3. It's really the same values we had exiting the loop. And now we evaluate right over here. We're going to add something to terms. So terms right now is 0, 1, 1. We're going to add something to it. What is that something? It's going to be the I minus 1th term of terms. So what's the I? I over here is 3. 3 minus 1 is 2. So this right over here is now going to be 2. So it's going to be the second indexed term in terms. So if the second, this is the 0th, the first, the second. So this over here is going to evaluate to 1. Plus I minus 2. Well, I is now 3. 3 minus 2 is 1. So plus the first term in terms. So this is the 0th term in the first term. So this is also going to be a 1 over here. So it's going to be 1 plus 1 or 2. 1 plus 1 or 2. So we're going to append a 2 to terms. That's what this does over here. And then we take whatever I was, which is I in this iteration, I is 3, and we're going to add 1 to it and redefine I to be that. So 3 plus 1 is 4, and that's the new I. Then we go again to the beginning of the loop. While I is less than or equal to n, well, I is now 4, n is still 5. 4 is less than or equal to 5. So we run this again. And once again, we need to figure out what terms of I minus 1 are. Let me write it over here since this is getting kind of messy. Let me actually clear this up because I want to be able to read it clearly. So let me clear this. So now in this loop, let's just think about what. So now let me write it over here. Entering the loop now, I is equal to 4. I'll do that same orange color. Entering into the loop, I is equal to 4, and the terms has now been, it now has 4 elements in it: 0, 1, 1, and 2. And now 4 is still less than or equal to 5, so we do this, and we have to figure out what terms of I minus 1 is. Well, now I minus 1 is 3, right? 4 minus 1 is 3. So terms of, or the third element, not terms of, I should say the third element in terms is 0, 1, 2, 3. So it's going to be, this whole thing is going to be this 2 right over here. So we're going to take that 2. I know you can't read that. We're going to take this 2, and we're going to add it to terms, the I minus 2th terms. I is 4. 4 minus 2 is 2. The second term in terms is 0, 1, 2. It's a 1. It's a 1. It's this one right over here. So we're adding this 2 plus this 1 to now get 3. And we're taking, so this whole thing, when you add it, is 3, and we are appending it to terms. So terms was 0, 1, 1, 2. But now we are appending a 3 to the end of it. We're appending a 3 to the end of it. And then we're saying I is equal to I plus 1. I was 4. 4 plus 1 is 5. So that is what I is equal to now. It's equal to 5. Then we go to the beginning of the loop. I is now going to be equal to 5. Terms, let me write in that same color for consistency. Terms are now 0, 1, 1, 2, and 3. And then we say, well, I is less than or equal to n. N is 5. Well, 5 is still less than or equal to 5. It's equal to 5, so this still is true. So we will execute this clause. And now we have to figure out, let me clear this out again. Now we have to figure out what is terms of I, or what is the I minus 1th term in terms. So now I is 5, so it's 5 minus 1. So it's the 4th term in terms. So 0, 1, 2, 3, 4. So it is this term right over here. It is the 3. It is the 3. So this over here is 3 now. And then we have to think about, let me do this in another color. And then we have I minus 2. I is 5 now. 5 minus 2 is 3. The third term in terms, 0, 1, 2, 3, is this over here. So this over here is 2. So you evaluate this. You'll notice we're just adding the last 2 terms that we had so far. This is how we build our Fibonacci sequence. And so 3 plus 2 is 5. So we're going to append a 5 to the end of terms. So terms is going to be 0, 1, 1, 2, 3. And then we are going to append a 5 to it. And then we say I is equal to I plus 1. So I is equal to 5 plus 1, or 6. I is equal to 6 now. We go to the beginning of the loop, and it says while I is less than or equal to n. Well, now I is 6, and n has been 5. 6 is not less than or equal to 5. So this says false. So we break out of the loop, and we go to, I guess, we stop running it. And then we go to return, return the nth term in terms. So remember, n was 5. So what's the 5th term if we start at 0? So this is the 0th term, 1st term, 2nd term, 3rd term, 4th term, 5th term. And we are done. And hopefully that gives you an understanding of why this worked, and also a little bit of the logic of how we wrote it. It's literally building up the Fibonacci sequence the way you would expect to. It started with the first 2 terms by definition. And then each time we went through the loop and it added another term, it said, hey, just the new term is just going to be the sum of the last term right now and the second to last term. And add them together, and then that will be the new term. And you keep doing that. Until you've added that nth term.